Compounds X, Y, and Z are in equilibrium. The diagram shows the effects of temperature and pressure on the equilibrium yield of compound Z. Yield has to do with how much we make. And normally, we refer to yield for the product, yeah? With a reversible reaction, it's not as obvious though, because with a reversible reaction, you could technically make the stuff on the left as well, because they're both in the mixture, yeah? But normally when we're talking about yield is the stuff that's on the right-hand side, because that's what we want to make, okay? So one of the first things you want to check, if they've told you equilibrium yield of compound Z should be a product, so it should be on the right-hand side of your arrow. Once again, it's not super obvious because sometimes Z might be on the left. You're still capturing the Z even though it's a reactant. Because it's a reversible reaction, you make a mixture of things, yeah? So this is one thing to check, but it's not going to be the best one to determine your answer. But in this case, it didn't matter anyway because all of your Zs are already on the right-hand side of the arrow, okay? But just something to watch out for. When they refer to yield, that's normally the product, which is normally on the right-hand side. So we get two pieces of information here. We get pressure. MPa is megapascals. MPa is megapascals. That's pressure. And then we also get given temperature. So let's look at it one by one. Yeah. This is 10 megapascals. This is 30 megapascals. And this is 50 megapascals. So each time the pressure has gone up, the curve for the yield has actually gone down. Okay, so when you increase the pressure, the yield has decreased. We've already established that compound Z is on the right because all four equations show it on the right. And also we're getting a yield of Z, which means it's the product, which means it's normally on the right. If we've increased pressure and the yield has gone down, what does that tell you about which way the equilibrium shifted? Z went down, which means we made less Z. So did the equilibrium shift to the right in the direction of Z? Or did it shift to the left away from Z? Left. It shifted to the left away from Z. Okay, so when you increase pressure, the yield has decreased, which means that the position of equilibrium shifted left. Okay. Now, we need to use this information to select one of our equations. Yeah. When we increase the pressure, the system wants to decrease the pressure. Okay. What did we say in the theory that we just learned then? If the system's trying to decrease pressure, which way does it shift? More moles to make more moles or to make less moles of gas? So my question is, we have increased the pressure. The system, according to Le Chatelier's principle, would want to decrease pressure. When the system decreases pressure, it's going to shift aside with less moles of gas. Okay. So this is from Le Chatelier's principle, and this is from the graph. Okay. So the information up the top is from the graph. This one down here is from Le Chatelier's principle. We can now combine these two pieces of information together to select our equation, okay? From the graph, we figured out that the position of equilibrium shifts to the left, okay? From the graph, we figured out that the position of equilibrium shifts to the left, and from Le Chatelier's principle, we know that it has to shift to the side with less moles of gas. So combining these two information together, if it shifts to the left, and LCP says it's shifting to the side with less moles of gas, that means that the stuff on the left-hand side of your arrow has to have less moles of gas than the stuff on the right-hand side of the arrow.
I'm a bit confused.
Yeah, that's all good. I figured, yeah. There might be something here because it has to do with a little bit of what you did last lesson, okay? Guys, there is a difference. So even if you've got it, this explanation will be helpful for you in terms of some of the stuff we got confused with last week, yeah? There is a difference between when the question gives us what we do versus how the system has already shifted, okay? Because the questions that we were normally doing last week, we always started off with, oh, what would the system do if we increase temperature? What would the system do if we decrease pressure, okay? So in that sense, we started off at what we did and then moved over to what the system does, okay? That was the main direction of thinking that we used last week because I had just introduced you to the theory. We wanted to keep it simple, yeah? What you're used to, because that was how you were introduced to it, was this is what we do, this is what the system's going to do. you need to be able to identify what information the question is giving you so you know which line of thinking to do. In this case, it might be a little bit confusing for some of you, and that was why it was confusing last week, but most of you are getting it now, is they've given you information about the change. Okay, they've given you information about the change and how the system has already responded to the change. Okay, so last week you got told this is what we do to the system. Tell me, what is the system going to do? Okay, in this case, they've already told you the change that you impose. Yeah, they've already told you the change that you impose. And normally last week you had to tell me what the system's going to do. But in this case, the graph has already told you what the system will do. How do we know that? Because we were able to figure it out. We increased the pressure, and from the graph, the yield went down, which means the position of equilibrium must have shifted to the left. So that's what the system has done, okay? In which case, this isn't the same kind of question you got last week. Because we already know what we did and what the system did in response to it, we have to combine what the question has told us with what we know about Le Chatelier's principle to get enough information to figure out our graph, okay? So even though the question told us which way the position of equilibrium shifted, it shifted to the left because we figured that out from the graph. We need to be able to figure out which equation would cause it to shift to the left, yeah? So using LCP, we figured out that, oh, when you impose this change, the system would shift to the side with less moles of gas. So we combine that with the information from the graph and realize, oh, when we go to select our answer, the stuff that's on the left-hand side should have less moles, because that's what I figured out after combining information from the curve with my information of Le Chatelier's principle, okay? So once again, the question told me from the graph, I figured out that it shifts to the left, but that's not enough information because I need to know that 4 equations are different. So I need to know what's different about the 4 equations. Yeah, the position of equilibrium can shift to the left for any equation. So combining the information from the graph with Le Chatelier's principle, I know that the stuff on the left has to be the stuff with less moles of gas. So information from the graph with my Le Chatelier's principle. Can I get a thumbs up, guys? Does that clarify things a little bit for us? The approach you take depends on what style the question is in, okay? The approach you take depends on what style the question is like and what information they've given you. Last week, I just told you what we do, and you tell me what the system's going to do. In this question, we know what the system's done, and we know from Le Chatelier's principle as well. So I'm combining absolutely everything just to figure out what the equation is. Okay, so last week, you got given the equation. Now we're figuring out the equation. So we're shifting to the side with less moles of gas on the left, because we know it shifts left, and it shifts to the side of less moles, which means combining those two pieces together, the left must have less moles. Over here, how many gases here?
4.
4 on the right?
Yeah. And then 2 on the
right. Good. And equation 2b is the same. So that's 4 and that's 2. What about equation C? How many gases on the left?
2.
2. How many gases on the right?
3.
3. And equation D is the same. So 2 and 3. All you're doing is adding up the numbers at the front of the coefficients. Yeah. So this is 2. This is 1. So together it turns into 3. Okay. So then I know that left has to be less moles, which means I have to pick either C or D. I still have to digest my temperature information, which is why I still have 2 options left. Yeah. But I cross out A and B immediately, because from my interpretation of the graph, I know that the left side has to have less moles. So A and B are going to be wrong, okay? Can I get a thumbs up, guys? Are we following that so far? I just crossed out A and B because I want less moles on the left, not more moles on the left. That's all that one was, yeah? Okay, so that's my information from the pressure side. Now let's go to the temperature side. So Samra, this time, when we increase temperature is going that way. What happens to the yield of compound Z each time?
It increases?
It increases, good. So when you increase the temperature for each of the curves, it starts going up that way, okay? So when you're increasing temperature, the yield increases. So help me out with this again, yeah? So Daniel, this time, we're going to digest the information from the curve first, and then we'll figure out LCP afterwards and then combine it together, yeah? So Daniel, increasing temperature increases yield of compound Z, okay? So if the yield of compound Z increased, what did the system do? Did it shift to the right or did it shift to the left? Where's Z?
Shift to the right.
Good. The position of equilibrium shifts to the right. Now help me out in terms of LCP as well, yeah? When we increase temperature, what does the system want to do? When we increase temperature, what's the system going to want to do? Decrease temperature, and which reaction decreases temperature? Endothermic or exothermic? Endo, good. Decreasing temperature means we want to absorb that extra heat, so it's going to be the endothermic reaction. And the endothermic reaction shift, just one last thing, is that delta H positive or delta H negative? Positive. Endothermic means delta H is greater than 0, yeah? So now, guys, I combine my two pieces of information together. The equilibrium shifts to the right and delta H is greater than 0. So what's my answer? C. Okay.